All right, here we go. We're just doing a little bit of regression, correlation, a little bit of wisdom that goes along with it. We will be using the calculator, so make sure that you do have your graphing calculator. We're going to be going back and forth. We're going to do a pretty cool outlier problem with little kid data, so that will be fun. All right, so couple of things, and we have done this somewhat today, and we did an example yesterday, but plot your data, get a scatter plot. First and foremost, make sure that it's linear, okay? Make sure that it's linear. That's important before you continue on with your problem. And then assess strength, direction, and form. Look for outliers. You can't just delete outliers like we did an example today of like, let's look and see what happens. I can't just get rid of the 9 beers and the 0.19 BAC. You can't just get rid of it. But the purpose of deleting that today was to show you how it does influence, okay? But if you just don't like particular data, that doesn't mean you can just get rid of it, okay? So look for outliers. Outliers will affect your R, because your R is made up of mean and standard deviation. Your outliers will also affect not only your R, but obviously your X bar and your Y bar, because they're averages, and outliers will affect averages, right? It will also affect your standard deviation. If this starts to fall, you just help me out if you see it. Thank you. All right, so here we go. So make sure you know your numerical summary. We did a problem yesterday with X bar, Y bar. Okay, the regression line always passes through X bar, Y bar. And then we did one where we found our slope, and that formula is on your formula sheet, and that is B equals R times S sub Y over S sub X. So don't forget that formula. And remember, you have to be a brilliant at arithmetic, right? You have to be a BA in statistics, brilliant at arithmetic. You're going to find your B first, and then you come over here and you do your formula, and you're going to plug X bar and Y bar in for X and Y, and then of course plug your B in, and then the last thing you get is your A value back, okay? So that's why we need to know all of this good data right there. Then what type of mathematical model is it? Should it be exponential or should it be linear, okay? Like, try to decide what type of curve or non-curve would fit it best, and then look to see how well it fits. So when I ask you on the test, how well does the LSR fit the data? How are you going to tell me that? R squared and residual plot. Put underneath that residual plot, okay? Yes, sir.
So if your scatter plot's not formula quadratic, do you have to make a quadratic equation?
You are not going to have to do that on this test. But yes, we'll do it next chapter. So if it comes out to look exponential or quadratic, think about quadratic. Quadratic's x squared. Guess what we're going to do? We're going to undo an x squared by doing what? We're going to take the square root of it, right? Okay? And then we are going to, if it's exponential, we're going to do the opposite of exponential, which y'all are going to love to hear, logarithms, okay? So chapter 4 is a doozy. So we're going to straighten out any curved pattern that we have. It's called linearizing data, okay? Chapter 4, I think, is the toughest one to kind of grasp, but you're really doing the same thing over and over and over. So if you can just accept that, then you'll be fine with it, okay? All right, so on this test, linear data. If it's not linear, you're going to provide an explanation, but you're not going to have to find a least squares regression curve or a quadratic regression or anything like that, okay? All right, so that's basically everything that we've learned so far. Now what we're going to do is we are going to put some data in the calculator in just a minute. Okay, correlation and regression, okay? Watch out. It only describes linear relationships, even though your calculator will give you an R and an R squared for exponential, quadratic, whatever you want it to be. But it only, in statistics, describes a linear pattern, okay? And that's as far as we go in AP Stat. Extrapolation can often produce unreliable predictions. Extrapolations, 0 beers and a negative BAC. That didn't make sense. It's pretty unreliable, right? So if you go outside of the range of data, you don't know what's going to happen, okay? We could have some crazy natural disaster and it throws off our, the stock market. So we're not in economics. We're not going to forecast what's going to happen. We only go in between the data. We call it interpolation. Is inside the data. Extrapolation's on the exterior. Okay, exterior extrapolation, interpolation inside. So we do interpolate. 5, 6, 7, 8. Everybody, interpolate. Okay, there you go. All right, right here. So correlation is not resistant. If you look at the correlation formula, R. Okay, and you don't have to know how to use the correlation coefficient R formula. You still need to look at the formula on your formula sheet and see that it includes X bar. Okay? Is X bar resistant? No. What about standard deviation? Is it resistant? No. Okay? So that means also correlation R, that's a really bad R, R is not resistant as well. Okay? All right. Heavily influenced by outliers. All right, so now what we're going to do is we're going to look for some outliers and see if we can find them, okay? So this is example 3.16 in your book, and it is, does the age at which a child begins to talk predict a later score on their test of mental ability? It's called the, I don't know how to say it, Gazelle scores. So anyhow, there is a test of mental ability. This is the age at which they began to speak, and this is their score. Now, I have a question. What kind of age are they talking about here?
Months.
Months, that's right. Okay, so we don't have somebody that's 42 years old and just began to talk. So these are in months, okay? So now I want you to put all of this data, age, and does it predict the score? Okay, so that's what we're looking at. Go ahead and put all this data in your calculator. And then we get to fiddle, which is the fun part of stats.
Are you talking about what?
That's what happens when you taught for a long time and used calculators your whole life, right? Now, I could be completely wrong though, Rita, so. And I'm known to put data in wrong, so. Let's make sure we got it all. 10. Nothing like the sound of calculator keys in the morning. And I messed up somewhere. 91, 102, 87, 93, 100, 104, 104. 102, 100, 105, 57, 56. Perfect. Perfect. Uh-oh, 15, hold on, what was that? 18, 11, 8, 20, 7, 9, 10, 11. Oh, I didn't put 2 11s. 11, 10, 12, 42, 16, 11. All right, here we go. I think I've got it all taken care of now. Okay, so go ahead and do what you need to do with everyone. We're going to use this example, go through everything that you should know. So first thing we want to do, let's do a scatter plot, make sure it's linear, okay? So we have second y equals, stat plot is on, L1, L2, and let's zoom 9, and let's just see how it looks. All right, so if I look at this, turn this off and see if it works. Hopefully yours looks about the same. Does yours look about the same? If you look at this, it almost appears that we have what type of direction going on there? A negative direction, absolutely. So I definitely see a negative direction, which makes sense. So as months increase, so if it takes a child 3 or 4 years, right, to speak for the first time, then their score on a mental ability test might be lower, okay? That's probably not always the case, but that's what it looks like the trend is going on right here, okay? All right, so we see that. Does it appear that we have an influential point? Does it look like we maybe have two influential points? So look at this right here. It looks like we have a vertical point up here that looks a little high and outside of the range of the data. And then over here, the pattern of the data. And then we have this little dude right there that looks like he's outside of the pattern of the data as well. Now, a vertical outlier doesn't necessarily do anything. The slope will remain the same. It might make it inch up a little bit, but it doesn't necessarily change the slope, which is the relationship between, that's what slope is, right? It's the relationship between y and x. This dude right here, though, actually gives this regression line a direction to go in. So if he wasn't there, so if this dude wasn't there, the regression line might be able to go right here or right here. There might be, several different ways that we could draw a regression line. But because he's here, we are going to try to draw the line that sends me in his direction. X outliers are much more influential than Y outliers because they give it direction, right? And they give your R more strength, okay? So we're going to look at this whole thing right here. All right, so now that we see that one, now I want to go ahead, let's put a line in there. So go to Stat Calc 8, and we're going to store a regression line. We're going to end up calculating 2 lines. I'm going to take old dude out of there, and then we're going to look, okay? All right, so at store regression line, you're going to go to vars, over to y vars, enter, and then enter on y1.
Why do you do that?
Because that stores your line so that we'll be able to see the line on the graph. So go to store regression equation under Stat Calc 8. Vars, y vars, enter, enter. All right, so now look at this data right here. Let's see if we can describe everything. So we have y hat equals 109.87 minus 1.13x. Y is our score on the mental ability test. This is the month at which they spoke the first time. Okay? So we could probably go ahead and come up with our y-intercept Mad Libs and our slope Mad Libs, okay? So here we go, y-intercept right here. This is our A value. I predict, now I'm not going to write it down, but let's see if we can interpret this. Isn't this 0,109.87? Now, this is an X and this is a Y. What does X stand for again? The month at which you spoke, the age at which you spoke. And this is your score on a mental ability test. Does my y-intercept make sense at all? Does it? Does my y-intercept make sense at all? At month 0, when I spoke for the first time, that's what I made on the mental ability test. Can you speak at month 0? No, okay? So absolutely not. So this is nonsense, okay? So I predict for a child who speaks at month 0, their mental ability score will be 109.87. Doesn't make sense. All right, so now what we have is our slope. Notice our slope is a negative, so negative 1.13. Always put it over 1, changing y over changing x. I write this every time just because it helps me organize. Y is the mental ability score. X is the month at which you spoke. So I just organize it, organize it, organize it. After I have it all written down, just so I have it clear in my head, now I can do my y's of a 1, my y's of a x's, okay? On average, I predict for every 1 month increase at which the child spoke for the first time, their mental ability score will decrease by 1.13 points. Okay? So this is always increasing as the months go by, right? So for every 1 month increase before the child speaks for the first time, their mental ability score will go down by 1.13 points. Y'all good with those? All right, our R right there, how would you describe your R? Is it linear? Yeah, we noticed that. What direction is it going in? Negative. What is negative 0.64? Is that strong? Somewhat strong. All right, so we have a somewhat strong right here. I would go ahead and put R equals negative 0.64. Linear, negative, somewhat strong, negative linear association. All right, somewhat strong negative linear association. Okay, but now let's go through and let's figure out, oh, what about my R squared? 0.4099, 41%. 41% of the variability in your Y, 41% of the variability in test scores is, what's the famous word? Explained, right? 41% of the variability in test scores is explained by the LSRL, which relates test scores to month at which spoken for the first time. A child speaks for the first time. So make sure that you can interpret that. All right, so now let's get to the fun part about this. Let's go ahead and decide who this guy is, and let's see how influential. We're actually going to do 2 different ones, okay? Let's start with this one up here, the vertical outlier. So trace until you find that person. There, okay. So our vertical outlier here, and remember, a vertical outlier is not really influential that much. So it is 17 months and 121. So it looks like, it didn't take them that long to speak, but they had a very high mental ability score. All right, so if I took that value off, okay, and what was our R value again? That's kind of important. 6.4, okay. All right, so now I'm going to take that vertical outlier out. So let's go back to Stat Edit. And we're going to take out 17, delete, and then 121, delete. Take them out. Now, go back and watch what we're going to do. Stat Calc 8. I want you to put a new regression line. I want you to put a new regression line in Y2. So go to vars, over to Y vars, enter, go down to Y2. So it's going to say Y2. Calculate. All I want you to do right now is, now look what happened to my R value. Hmm?
64 is negative.
Okay, but look at my R value. Did it make it stronger? Okay, did it influence my line? So just press graph now, just graph. There's the first line. There's my second line. Did it necessarily change the slope that much? No. Okay, did it make my R stronger? Yes, because this has a large residual. It's very far off of my regression line, okay? So it made it more spread out, so we know that that influences our R. Which one affects the regression line more? This little dude right there. All right, so now come over here, go to Y equals, press Y equals top left. Delete this Y2. I don't want it anymore. There we go. So now all we have is our original one in there, okay? All right. Now go to Stat Edit. Go all the way down and let's add back in our vertical outlier, please, at the bottom, which was 17 and 121. So add back in your vertical outlier. It doesn't matter where it is in the list. Now, let's take out our horizontal outlier. So press graph again, and I want y'all to figure out what that point is right there. So press trace. You can probably already tell which one it is. Oh, there it is, 4257. Is that who you have? Okay, so now go back to stat edit, take out 42 and 57. There it is, 4257, take that out. Delete, delete. What should I do now? Stat Calc 8, we're gonna do a new line. So go Stat Calc 8 and go to store regression. And I want you to store it in Y2 again. So vars, over to Y vars, enter, go down to Y2 because I have my original one in Y1. All right, calculate, and don't press zoom 9, do graph so it keeps the same window range. Whoa, what happened to my R? It actually dropped a whole lot, right? The other one increased it, this one decreased it. All right, so now just press graph. Here's my original line, my point is missing, and now here's the other line. Do you see how it influenced it so much because it was down here, right? And so it absolutely does change the slope of the line and the strength. All my strength is gone now, right? So all my strength is gone. So I definitely want you guys to be able to see that as far as the graph goes. All right, so just one more thing I'm going to show you on the notes and then we're done. All right, so absolutely, again, ask yourself who, what, when, where, why. Interpret, make sure you mention outliers. When I ask you this question right here, how well does the LSRL fit the data? There are exactly 2 things you should tell me on the test. Find this slide, looking for outliers. How well does the LSRL fit the data? What are the 2 items you're going to use? R squared, absolutely. What's the other thing? Residual plot, residual plot. So R squared right here, how well does the LSRF fit the data? R squared and residual plot. Got it? All right, so here we go. There's our child 19, here's child 18. And you can see child 19 is further away, larger residual, but so it affects the R. This one over here affects your R, gives it more strength than it actually should have, okay? All right, you can definitely see it's much more influential than child 19. All right, so an outlier is something that lies outside of the data. It is influential if it will change the statistics. It'll change your slope. It'll change your y-intercept. It'll change the R value, okay? So you can definitely see influential points, okay? All right, last thing, lurking variable. This is a variable that is not plotted on the X or Y, okay? But it might influence. So it might be the economy, an election coming up, okay? All those different things could definitely be in the background of a scatter plot or a regression line or a graph that really could influence the data, okay? So if I were graphing the number of ice creams sold in Portland and the number of Teslas sold in Florida, like the number of ice cream sales and Tesla sales, they don't necessarily shouldn't be graphed together, but the lurking variable would be the economy, right? So so you definitely could have a lurking variable there, okay? All right, a strong correlation does not imply causation, okay? Goods imported and private healthcare spending, they show this wonderful relationship, but just because there's a correlation does not mean that one is causing the other to happen. I already showed you guys that on some terrible graphs if you were in here, that there are some really terrible graphs. You could, so there was one, I hope this isn't on your test. but it could be. I don't know. This is from some test I gave. It showed a rise in organic food sales on the x-axis and a rise in autism. So, is organic food causing more people to be autistic? No. Okay, is organic food a little bit more accessible now than it used to be? So people buy more organic food now. Is autism something that we test more now for? Is it something that's kind of been brought to light over the past 20 years? Okay, 20 years ago, if you were to ask what percentage of the population has signs of autism or is autistic, you wouldn't have known because it just wasn't something that was tested for. Are y'all following me? Okay, so you can plot them and both of them are increasing, so it has a line, but that doesn't mean that one is causing the other to happen. Okay? All right, we're done with chapter 3. I'll let you know how many questions are on vocabulary in just a few minutes.